file that I've just opened, which has all the um, tests that we need to do today. That is independent sample t-test and paired sample t-test. And we'll be using the dataset Iris. Iris was a small data set that we have used before also during our tutorials, like not tutorials, demos. So I'll just make this, I'll just readjust the terminal so that we can see the whole thing. So the first step that you need to do is definitely you need to import the data that you need to use. Iris is a data set that is already available in R. You don't have to import it from anywhere else or from any other package. You just have to type data Iris and it should ideally load, and whatever it loads it will show you in the environment. This is the environment section of R. So this is now loaded to the environment, that is like loaded to the current session that we are having. For us to view it, we can't view it if we press it now. So like after loading it, we have to type Iris manually and just run it. So now you can see the data is clickable. It's a clickable option right now. You will see like a very small first few lines, first 10 rows of this particular data set. For you to see the whole thing, you just have to double tap on this Iris in environment, and it will show you the whole data set. Okay. So, so now that is loaded and we know how the data set looks. So let's scan through the data set first. So whenever you get a data set, the first thing that you do is you just skim through the whole data set. How big is it? What all things are there? So on a layman's view, what I'm understanding is there are 5 columns: sepal length, sepal width, petal width, and species. Just to give an introduction about the Iris dataset, if you do not know what it is, so Iris dataset just has a very small dataset, which gives you, the petal and sepal width and length of like 3 categories of flowers. Okay, there is one category called setosa, another called versicolor, and there's also something called virginica. So there are 3 categories of flowers and their respective petal width, petal length, sepal width, and sepal length given. Okay, so this is all about the data set, and all the values are in numbers, while this one column is completely string. Whenever we say string just means like alphabets or words. This numerical means obviously we are using numbers. Okay. Well, coming to the first aim, that is how to do independent sample t-test. In layman terms, you do independent sample t-test when you want to compare between 2 groups of data based on one variable. That is like, I have given an example which is very relevant to us, like academic satisfaction of participants of our RStats initiative versus that of non-participants. So you have one variable that is academic satisfaction, and then you have 2 groups of people. So you are trying to find a difference between 2 groups of people based on one common variable. So here it is academic satisfaction, right? So this is an like psychologically relevant variable and a question. That's why I've just put it there as an example. But we have to get back. We have to work on this data set. So we'll be having another question. So here we will try comparing the sepal length of 2 categories. That is the Setosa species and the versicolor species. Okay. So we have the common variable, that is the sepal length, and we have 2 categories. That is, one is Setosa and another is versicolor. So for that, what we need to do first is like out of the Iris data set, we need to isolate the Setosa and versicolor. So here you can see like we have the first so many sections are Setosa, then we have so many sections of versicolor, and then we have virginica. We don't need virginica, so like we need to separate it. So one thing with R is like right now, like how you can see sepal length and sepal width. When we are trying to do a group comparison, let it be paired sample t-test or independent sample t-test, either ways R requires you to put values in 2 adjacent columns. That is like, for example, here instead of sepal length, it should be versicolor, and here it should be the other one, that is a setosa, and the respective scores should be coming here, like in the rows. So So that is how R requires you to put the data so that you can run the test. So for that, you need to particularly isolate the species. Okay. So for that, there is a little complex function that we use. It's not.
Mona, are you sharing the screen?
Yes, I am.
I can't see it.
Can anybody else see the R screen?
Yep.
Yeah, yeah, yeah.
Okay, wait. In my case, it was not pinned. So okay, I'm so sorry.
Right. Uh, okay, now it's visible for everybody, right?
Yeah, yeah, I can see.
Pooja, can you see it?
Yes, yes.
All right, cool. So, like I said, this is a
Your
little.
video got pinned and not the this one.
Okay, cool, cool. Got it, got it. So yeah, so this is a little bit complex code. It might look like a complex code, but we are definitely leveling up. So we will also learn how to do this. So whenever you see a complex code in any document, one thing that you can do is you can copy paste it to ChatGPT or Google and ask it to tell like what it means. Okay, so that's a very simple thing that you could do. So here what I have done is I have also written the meaning. We'll get to it later. Okay. So first I have written iris. So this is the data set's name, that is iris. And this is a dollar sign. For dollar sign, or dollar sign, when you put a dollar sign, it means what precedes the dollar sign. You want to, from that data set, you want to take something. So here I'm saying that from the iris data set, I need sepal length. This is this much code means that. Okay, the iris dollar sign sepal length means like from the iris data set I need sepal length. Then you open square back bracket and then you mention again, next section is iris again, that is a data set and a species. So you may be able to guess what it means. Now I need to say, like, I need to select species from the iris data set. So here we have a column called species, right? So I'm saying I need to particularly do something onto the species column of iris data set. So this is that from up till this clear, right? And then what I'm trying to say is that when you put an equal sign, you just are saying like something is being getting assigned to something. So when you, let's 1 second, I'll just type it here just for the sake easiness. So when you put this sign, that is like a hyphen and an uh, um, okay, when you use this function, what happens, it is an assignment operator. You're trying to assign something, like for example, one let's say like, okay, iris is getting assigned to another data set called data. So you're assigning something on the left side towards this side, or even if you want to reverse it, you can also reverse it like this. I think this won't work, so we have to put iris assigned to data, right? So another thing is also you can put also equal. It's just is an equal sign, which means like iris is equal to, let's say, 1 plus 2 plus 3. So you're trying to assign something again, right? So that is what the hyphen with an arrow or option, I mean operator means, and also the equal sign means. So here when you put double equal sign, it means it is. So it is like, so I'm saying I need to find setosa, like the word setosa in iris data sets species column. So within the species column of iris, I need to find exclusively the string setosa. That is like there is setosa written here. So I'm trying to exclusively pick that. So here altogether, so till here I have explained, and then I'm assigning it to a word, another variable called setosa, just for the easiness of it. So here I have written the meaning. So I said, first take out from the iris data set the sepal length, that is this much. When this species column in data set has the string setosa, that is this much. Okay. And then I'm saying, then assign it to the variable name setosa. So this much part. Now it's clear. Can somebody just confirm? Did you guys understand it? If not, I can explain it from scratch. Can somebody confirm for me?
It it was clear for me, and Irisha and Anubha have also sent a thumbs up. And yeah, everyone's sending a thumbs up.
Understanding, right? So, okay, here is when I want you guys to be active. So this is one, I explained this. Can one of you explain what this means? Anybody? It's not that difficult, guys. I will definitely tell you the answer also, but like, somebody please go ahead. We need to make it very interactive.
You know what? Could you repeat again?
Yeah, sure. So, okay. So let me just divide it like this for the purpose of it. Okay. Okay. So first okay, just ignore the cross sign. It just says that I'm doing something wrong. Just ignore that for the time being, just for the easiness of it. So this much part of the code means from the iris data set, take sepal length. This is what it means. Okay. So the first I've written the meaning, right? Take out from the iris data set the sepal length. I'll just copy paste here. Sorry, 1 second. Right. So yeah, this is what this much portion of the code means. Take out from the iris dataset the sepal length, the variable sepal length. Okay. Then I'm saying I'm putting another code within that code. That is, I'm putting a condition here. The condition is whenever inside the iris data set, whenever the column species of iris data set has the string setosa, when I put double equal, it means like is. It just means is. If for the easiness of it, I'm saying it is. It just stands for is. So you're trying to say when iris data set species column is setosa. So this is what it means. So when you come, then I think I should pick this also. See, this is the second section of the code, and the third section of the code is just assign this. Then after doing all these things, assign it to the variable name setosa. Got it? Is that? Do I repeat it again? I can repeat it again if you want.
I think I got it this time.
You got it this time. Okay, perfect. I'm just undoing it and just going back. So, okay, all together, again, let's just go with this. So there are three sections. It can be easily divided to three sections. The first section of the code is within the iris data set, choose the column name sepal length. When the species column has the string value setosa, and then assign it to the variable name setosa. Okay. So now that I've explained this, now you might be able to explain this as well. There's only a very small change. Can anybody give it a shot now?
So like instead of setosa, in the second step, that is the iris dataset species column,
Right.
equal is setosa. There we substitute that with versicolor.
Correct. So it's just the same thing. So I can literally copy paste this and put it here and say when it has a string versicolor and assign it to the name versicolor. Okay, this much is done. So now we will be having, let me run till here first. So when you're running also, you have so many options. See, like I can run the selected lines. So it did run. So here you can see their values are isolated. So the values of setosa is isolated here, and also versicolor is also isolated. Now the t-test code is very simple. You just have to type t.test, and in brackets you have to put setosa, comma, versicolor. You can also add paired is equal to false. Even if you don't add this also, it will work. I'll just run the whole chunk and show you.
So like
Yeah.
by default, it is considered as independent.
Yes.
Okay.
But just for your, like, in case, like, if you want to make it any easier, we can definitely do that. Whenever you put paired is equal to false, you're trying to say it's not a paired test. It is it is an independent sample t-test. That's what you're trying to say. At here, there is a small error that I'm understanding because it's not showing. Just give me a second. I'm not really sure why it is not showing right now. It ideally should be showing.
Do you think it could be because like we made a vector of this instead of having it in a data?
No, I did try I did try running the thing, the whole code, and it did show earlier the results. I'm not really sure why it is not showing right now. Okay, this is strange. Okay, just give me a second. I'll just close it and open it again.
T-test works with vectors, right?
It does, and in fact, it did work before when I tried, but I don't know why it didn't work now. Thought I was just wondering. The output is not showing for some reason. Okay, I'm just gonna stop sharing for a second. I'll just fix this and get back. Give me a second, okay, guys?
Also, do we need to mention that var equals equal?
I don't think so because it did run earlier, but I'm not really sure. I think it's a settings related issue from my R. So I just need to check that. I'm not really sure why suddenly it stopped working.
I think if it doesn't work here, maybe you could show it in ChatGPT. Like ask ChatGPT to show the output.
No, 1 second. I did something just for the time being. I'll just fix that later. Okay. So right now, okay, so the steps all remain the same, and this is the code that we use, and it should ideally be working. It's a settings related issue that I need to fix later. But for the time being, I can knit the file and show you guys. So it just means this. Can you see this file?
Yes.
You can, right? Okay, fine. Okay, so the result of this particular 1 second. Yeah, this particular code gives you this result. Okay, so it gives you a t-value that is minus 10.521. That is the t-value. then the degrees of freedom is marked as 86.538, and the p-value comes in scientific notation. It's just like when you copy paste into Google, you can see how much of a small number this is, so it gives you that result. That is, it's very close to zero. So that is one thing with R gives you more, automatically gives you in scientific notation. Whenever you see something like this, like you can already assume that it's very, very small p-value. And it also gives you the confidence interval. The first one might be the lower value, and the other will be the upper confidence interval. And obviously the mean values of both the variables will be given. Here's something that you need to take care of it. This will be coming in the order in which you have put in your code. So here, since I put Setosa first, this is Setosa's mean, and this is versicolor's mean. Okay, so this will be the value, this will be the variable x, and this will be the y. So that's why it's like mean of x is this and mean of y is this. So that is the thing with independent sample t-test. And now when you do paired sample t-test, here when you, again, when it comes to paired sample t-test, the difference is like now you're going to compare one group of participants, or one group of participants based on two variables. Let's say, but again, those are supposed to be related variables. So one such example based on the previous example I mentioned is academic satisfaction of participants of Psychostats club before versus after joining the club. So there is like same set of people, but being assessed at two different times. Or maybe like, let's say, the same group of people are yeah, so let's just go with this for the time being, not create more confusion. So let's say before and after, it's the same sample, but you have two separate data of theirs. Or let's say there might be the same set of people going through two games, and their scores in two games, like game 1 and game 2. It's the same person having two scores. So you're trying to compare between two games, which one did they score better. So here in this example, we can say like, how is the difference like before and after joining the club? So that is a question that that's a possible question that we can have. So here again, you can load the data set if you want, but you don't need to because it's already loaded here in the environment. But imagine you're not doing the independent sample data, and it's the first time that you're loading data, then you have to repeat this. Otherwise, it's okay. And even if you repeat it also, it's okay. It's not going to overwrite or anything or create any other problems. It just is not necessary again. But I have added again nonetheless. So now the question is, we are trying to compare the sepal length and sepal width of the same species, that is Setosa. So here you can again, like it's the same kind of code, but the difference is here you have two choices to make. Here is this sepal length and this is sepal width. And remaining everything stays the same for both the parties, right? Both the datas. And then here when you do paired sample t-test, it's just similar code, but just that in the paired is equal to, you have to give true. That is, it is paired. It is a paired test. Then you run it. Definitely, again, it should have worked here, but it didn't work. So I'll just show from here. So here also you can see the t-value is given 42.323, and the degrees of freedom is 49. And the p-value is again, it's again a scientific notation, which means like it's a very small p-value. And again, like you can see the lower confidence interval and upper confidence interval. And here you will only see the mean of differences because it's just one group that is being compared based on two things, or like compared at two different time points. So you will have only one mean of difference, that is 1.578. So here you can see that there is a significant difference in terms of length and width. And let's also try looking at the data set. So here, if you see, here we have like sepal length and sepal width. Here is like 5.1, 3.5, 4.93. So like overall, like if you scan through it also, like you kind of sort of understand it. But again, those are just like superficial things that we can do. We always have to run one or the other statistical test to finally understand what means. So yeah, I'll be definitely sharing this document in the group like the other times. So you guys can go through the same RMT file. I'll try converting into PDF file so that you guys can repeat it if you want. And always feel free to copy and paste it onto ChatGPT and ask what each chord means. If you're not able to find, let's say, like in this chord, when you're not, if you don't want to understand the whole thing, if you want to segregate it and understand what does this part of the code means, you just have to select that part of the code and you can enter it. However you want to learn it, you can learn it. So based on the meaning that I've given here, you can try creating meanings for these two. This is like do it yourself part 1 and part 2. So that will be a small activity for you guys if you are interested in doing that. So I think that's it. If you have any questions, you can feel free to ask right now. Is there any question?
Munna, I had a doubt. Like the output that we get on R is
Yeah.
like, is it one-tailed or two-tailed?
Right.
By default?
That okay. How about we do like finding this answer in like right now, so we can try finding. So let's go to ChatGPT, and this will be a training for you guys to understand how we Google stuff.
Yes.
Yes. So just ignore all the on the side, whatever you see, just ignore it. Okay, so the question is, let's just even select the chord. So for example, here, this is the chord that we used for independent sample t-test. Let's say to ChatGPT, I used the following code to conduct independent sample t-test. Is it two-tailed or one-tailed? Again, there are so many ways in which you can do it to t-test. There's not only one way, so it will probably give you another way as well. So let's see what ChatGPT says. Okay, I hope you guys can see it as well. It is an automatic two-tailed test. So, yep. We can also ask, like, is there any other way to do it? Yeah, so it's already giving you the answer, like almost here. If you want to perform a one-tailed t-test instead, you can specify alternative hypothesis using alternative parameter. So here they have given another code. We can, how about we try doing that? So this is automatically, it's a two-tailed one. And this is apparently going to be the one-tailed one. But here the question is, in what direction is it going to be assessed is a question that we have. Yeah. Right. So here, like, so the first one is this data. This is the code for two-tailed, and this is the result that we got. And then this is a one-tailed thing. So there's an you just have to add alternative is equal to less and try doing that. And I think there must be some other ways to do it as well. So, okay. So if you want to perform one-tailed t-test instead, you can specify the alternative hypothesis using an alternative parameter. For example, if you want to test if the means of setosa is less than the mean of versicolor, you can use less. If you want to check it, if it's greater than the mean of versicolor, you can use greater. So yeah. Did you understand, Pooja?
Yes, I got that.
Right.
So, but usually we mostly just look for if there is a difference or not, and from the anyways in descriptive stats we see the means. So we usually get it from there, right?
Right. So yeah. Anyways, I think I shall remove this for the time being, just to avoid confusion. I'll just mention it's a tutorial there.
I mean, have you ever tried to run like directional t-test? I usually just do two-tailed, and from the means it makes sense like which way it is. So,
Right. I always have done two-tailed test.
yeah.
Yeah. So always doing two-tailed is a better idea, but then I mean there are so many parameters that you might need to take into consideration before making that decision, including the data distribution. Those are little more advanced topics, and like e- even the p-value, the alpha value, all those kind of things, and null hypothesis projection can be a little bit tricky, especially the way it is framed when you say one thing is rejected and another thing is accepted, and all. It could be a little bit tricky because the sentences are phrased in a very tricky way. So it will take you a little bit time of practice to do it. So similarly, even with making decision of two-tailed and one-tailed also carry so many other factors behind it. So we might slowly discuss about it in later sessions probably. Is there any other
Okay,
question?
so if there are no other questions, then this is it then. And Anuba, also please share the PPT and everything so we can send it on Slack.
Sure.
Munna will also be putting this up. And thank you so much, Anuba and Munna, for this presentation. This was amazing.